Hello everyone, my name is Simon and welcome back to another video. Today we're going to be learning about DigitalLogic episode 1. In the first episode we're going to be talking about what is binary. So this is going to be kind of an informal tutorial about DigitalLogic. So first off, our first question is, what is binary? Well, binary is a number system which is used by computers, which is in base 2. Now, many of you don't know what base 2 is, so let me explain. Regular decimal numbers, so like 0, you'll have to excuse my horrible handwriting, 1, 2, 3, 5, 6, 7, 8, 9, are all in base 10. Also, we can go 10, 11. Now, with these numbers, they're all in base 10 because it's, like, let's take number 15. In reality, it's 1/10. This is looking like the Khan Academy episode, and 6 ones. Now, basically, we have 10 different symbols to represent any number. Like, we have digits. So, like, let's say we have 1,156. Let's say we're using the same 10 symbols for each one of these digits to represent a bigger number. Now, with binary, it's exactly the same, except for you're only getting zeros and ones. 2 symbols, base 2. That's where we get the name. Alright, well, in computer stuff, there's more than just binary. There's hexadecimal, but we'll explain that later. Now, right now, what we need to assign is basically the value of each digit. So, like, let's take, again, 1,156. We have that this is spot 0, spot 1, spot 2, spot 3. So, basically, since this is base 10, let's take this spot right here. This is 10 to the power of 2, or base to the power of the n. Now, since this is base 2, that means this is going to be 100, and so this is the 100 spot. See? Now, let's move further on. In binary, it's exactly the same, except for we're using, let's take the 00001, 5-bit number. Let's just do that. This is actually 1 in decimal. Decimal is standard notation for like 15, and binary is all the zeros and ones. Alright. So let's take like this spot right here. This is 0, 1, 2, 3, 4. This is 2 to the power of 3 equals 8. So this is the 8th spot. So, like, if we wanted to write 9, it would be 0, 1, because 9 is 8 plus 1. So we go find the spot where 1 is available, which is the first slot, because it's 2 to the power of 0 equals 1. So we go 0, 1, 0, 0, 1. Let's do a couple more exercises so you can start to understand this more. Let's take 15. 15 is 10 plus 5 in decimal. Or we can write it as 8 plus 4 plus 2 plus 1. Because each one of these is part of the number. So 15, this goes here, and this goes here. Same here. We've got 1 for the 8th spot, 1 for the 4th spot, 1 for the 2 spot, and 1 for the 1 spot. So in binary 15 equals 1111. Yeah, I think I said the right number. Alright, let's take a bigger number. Let's take 43. Alright, so in regular stuff, it's gonna be 4 tens and 3 ones. So it's going to be 43 in decimal. Now in binary though, it's going to be a little bit trickier. So we know that 43 is 1 plus 2. I've already written this out, so we're not going to go on like this. I'm going to teach you how to convert to decimal right after this. 1 plus 2 plus 8 plus 32. You'll have to excuse my handwriting. And this in total is going to equal to 43. Because these two are 3, 8, that's 11, plus 32, that's 43. So we know that our code is going to be, let's start on this side, in the 32 spot, which is here. We know that there's a gap in the 16 spot, and then we have 8, that's a 1. We have a 0 for the 4 spot because there's no 4 here. We have a 2 right here, and then we have a 1. So the code for 43 is going to be 101011. Now I'm going to simplify this, make it a lot easier on you. Let's take number 43 again and find the binary code. Now what we want to do is to find the least significant bit. A bit is either a 1 or a 0. So the least significant is the one furthest to the right. So here. So like imagine this is a binary number, a 4-bit binary number, because 4-bit means that there's 4 different ones and zeros. This right here is the least significant, and this right here is the most significant. So we have 43, and we're going to divide it by 2. And we know that that equals to 21. But we have a remainder. So we have 42 here. We have a remainder of 1. So we take that remainder and put it in order backwards. Well, we put it into the least significant. So we know that least significant for 43 in binary is a 1. Okay, let's continue. So now we take the quotient and then we divide it again. So in this case it's going to be a 10, 20, remainder equals 1. So that goes into the second least significant spot, and we just keep on going. So we take the quotient again. 10 divided by 2 equals 5. 10, remainder 0, so we put in a 0. Now we're gonna take this quotient here. We're gonna have 5 divided by 2. Oh, that's a 2. We're gonna have 5. 5 divided by 2 is gonna equal to 2. This is going to equal to 4. Sorry, it's slanted. 1, so we have a remainder of 1. Now we take 2 divided by 2. We have 1 here, 2 here, a remainder 0. And then we divide up until the quotient is 0. So we have 1 here. So let's go. So 1 divided by 2 equals to 0. And that means 0 down here, a remainder of 1. And that goes here. And so now we get the binary number 101011. And from the previous slide, we know that this is correct. 1010 and 11 equals 43 in binary. Now, let's do this with another number. Let's take for example, let's take a 3-digit number. Let's say 357. This is going to be a big one. Solve it for yourself. Alright. So, we're gonna clear this screen, make it a lot easier. We're gonna have 357 divided by 2. Oh boy. 178, I believe. And that's gonna equal to 356. Yeah, 356. Remainder of 1, so 1 here. Now it's gonna be 178 divided by 2. Oh boy, this is gonna be tough. Alright, I am back. I have brought my calculator with me now because this was getting a little hard. So this is gonna be 89, and this is gonna be 178. So our remainder is 0. Now 89 divided by 2 is 44. 88. This is going to be a remainder of 1, so we go here. 44 divided by 2 is equal to, I should know this already, 22. 44, remainder is 0. 22 divided by 2 is 11. 0, so 0 here again. Now we're going to have 11 divided by 2, and this is going to equal to, let's say, 5, 10, remainder 1. Alright, we have 5 divided by 2. This is going to equal to 4, or, dang it, we're going to have 2 here, 4, remainder 1. 2 divided by 2 is 1, 2, 0. And we're going to put that in there, and 1 divided by 2 is equal to 0, 0, 1, there, and here is the binary representation of 357. Alright, so now we know how to convert to binary, and we've understood what binary is. Now what we want to do is we want to learn how to go back to decimal, because a bunch of 1s and 0s isn't going to really mean anything to you from an output of a computer. So our step is basically to multiply the numbers by their value and add them up. So let's take let's take a simple number like, my pen is a little bit lifted up. 0, 1, 1, 0. Now, we know that this spot has a value of 1, this spot has a value of 2, this has a value of 4, and this is a value of 8. Now, what we can do from this now is just multiply the numbers. So, this is going to equal to 0 times 8 plus 0 times 4, or no, is going to be a 1 times 4 plus, it's going to be 1 times 2 plus 0 times 1, and this equals to 6. So 0, 1, 1, 0 equals to 6. That's how we get our answer. Let's do a bigger number. Let's take 1, 0, 1, 0, 1, 0. Alright, so this, we know this is 1, 2, 4, 8, 16, and 32. So we're going to have 1 times 32 plus 0 times 16 plus 1 times 8 plus 0 times 4 plus 1 times 2 plus 0 times 1. So if we add all of this up, it's going to be 32 plus 8 plus 2, and this is equal to 42. So now we've had our basic introduction to binary. So we've covered what is base 2, we've covered how to convert to, and we've learned how to we have learned how to convert from binary. Now I hope this is very helpful. In the next episode we're going to be talking about logic gates and how to sequence them together, and we're going to learn the proper notation for different circuits. Alright.